Have you ever imagined that a shining asteroid in the night sky could be worth more than your country's entire GDP? It sounds like science fiction, but it's pure reality. Somewhere, at this very moment, engineers and scientists are developing technologies to transform this space wealth into earthly reality. We live in an era where the boundaries between possible and impossible become increasingly blurred. The space race of the 21st century is no longer driven solely by territorial conquest or national pride. Now, trillions of dollars in mineral resources float above our heads, waiting to be explored. Just imagine, a single asteroid the size of a football field may contain more platinum than has ever been mined in human history. And we're not just talking about precious metals, elements fundamental to our technological revolution, such as nickel, cobalt, and rare earth elements, exist in abundance in space. But why exactly are countries willing to invest fortunes in this seemingly risky venture? The answer is closer to our daily lives than we might think. Your smartphone, your electric car, that solar panel on your neighbor's roof, they all depend on materials that are becoming increasingly scarce on our planet. The asteroid 16 Psyche, for example, which orbits between Mars and Jupiter, is composed primarily of iron and nickel. Its estimated value? Approximately $10,000 quadrillion. To put that in perspective, that's more than the entire global economy multiplied by millions of times. China has already announced ambitious plans to establish a space mining chain by 2035. The United States isn't far behind, with NASA and private companies like SpaceX and Blue Origin developing technologies to make space mining economically viable. Luxembourg, a country smaller than many Brazilian cities, has already invested more than 200 million euros in research and development in this area. But the challenges are as gigantic as the opportunities. How do you transport heavy equipment into space? How do you extract minerals in a zero-gravity environment? How do you ensure that the extracted material returns safely to Earth? These are just some of the questions scientists and engineers face daily. The good news is that technology is evolving rapidly. Autonomous robots equipped with artificial intelligence are already being developed to perform mining operations without direct human intervention. Imagine a fleet of intelligent machines working 24 hours a day, 7 days a week, in conditions that would be lethal for humans. And it's not just about mining and bringing resources back to Earth. Space mining could be the key to deeper exploration of the solar system. Resources extracted from asteroids could be used to produce rocket fuel directly in space, creating space filling stations that would enable longer journeys and more ambitious missions. The benefits extend beyond space exploration. Technologies developed for space mining are already finding applications on Earth. Water purification systems, new material recycling methods, advanced automation techniques. All these innovations were born from the need to solve problems related to space mining. But there are legitimate concerns. Who has the right to space resources? How do we ensure that this new gold rush doesn't result in international conflicts? In 1967, the Outer Space Treaty established that no country can claim sovereignty over celestial bodies, but the rules for commercial exploitation are still subject to intense debate. Environmentalists also raise important questions. While space mining could reduce pressure on terrestrial resources, the increase in rocket launches could have significant impacts on Earth's atmosphere. How do we balance technological progress with sustainability? The answer might lie in technology itself. Companies are already developing cleaner methods of space propulsion, and SpaceX's pioneering rocket reusability is drastically reducing the cost and environmental impact of space launches. The economic potential is simply astronomical. Conservative analyses suggest that the space mining industry could be worth more than $2.7 trillion by 2040. This means not only profits for companies and governments, but also the creation of thousands of new jobs in areas such as space engineering, robotics, and data processing. Developing countries are also eyeing this opportunity. Brazil, for example, with its expertise in terrestrial mining and privileged geographical location for space launches, could become an important player in this new market. Imagine a future where resource scarcity is no longer a limiting factor for human development, where green technologies can be implemented on a large scale without concern about the availability of rare materials, where space exploration is no longer limited by logistical issues. This future might be closer than we imagine. Every day, new discoveries and technological advances bring us closer to the moment when space mining will cease to be a dream and become an everyday reality. But what do you think about this new space race? Can you imagine a future where mining asteroids is as common as extracting oil is today? Leave your opinion in the comments and don't forget to subscribe to the channel for more fascinating content about science and technology. After all, humanity's future might literally be written in the stars. And the more we understand about this new horizon of possibilities, the better prepared we'll be to be part of this revolution that promises to transform not just the space industry, but all of human history. Remember, just a few decades ago, the idea of having a computer in your pocket seemed like science fiction. Today, space mining might seem distant, but tomorrow it could be as common as checking the news on your smartphone. The future is coming, and it's brighter than any star in the night sky.